Good evening, ma'am.
Good evening, ma'am. Can you try the first few? Are you able to see? Yes.
Good evening, ma'am.
Good evening. Good evening, Vatika. First four you try, after that we'll discuss the answers. Keep track of your performance and mind the time as well.
Good evening, ma'am.
Good evening, Jessica.
Good evening, ma'am.
Good evening. See if it's visible, otherwise. You bring graph sheets, Anna. I have 5. Did anyone complete it? Did anyone complete? Okay, I'll give you 1 more minute. Can we discuss? Yeah. Okay. First one. Can someone answer the first?
With option C.
Good job. Correct. Reason? Because the interval given is 0 to 3, okay, but open. Okay, but in between the numbers, integers are 1 and 2. You know, greatest integer is discontinuous at all integers. Greatest integer function is a step function, right?
Yeah.
It is discontinuous at all It will be like this. At all integers, there is a jump discontinuity. LHS limit at 1 will be 0. Okay. RHS limit at 1 will be plus 1. Okay. So there will be discontinuity at 1. So it wouldn't be differentiable there. Wherever it's discontinuous, it's not differentiable, right? Yes. So it's not differentiable at 1 and 2. So 2 points of discontinuity. So at those points, it wouldn't be differentiable. Next one.
C, ma'am. C, ma'am.
Correct. Many of you got it. Yeah. Because the first derivative is x power x into 1 plus log x after applying the logarithm. After that, if you apply product law, it will be x power x into 1 by x plus this. Yeah, so definitely. Third one.
Third one also C, ma'am.
Very
C, ma'am.
excellent. Yeah. Minus 2x minus 2 must be greater than 0 for increasing. Okay. Or minus 2x must be greater than 2 for increasing. Or x must be less than minus 1 for increasing. We are reversing the inequality, but increasing will still remain the same, right? Okay, so for x less than minus 1, it's increasing. So this is the only choice. Intervals in which it is strictly increasing.
A.
Very good.
A, ma'am.
A. Yeah, because the first derivative is cos x minus sin x, but we know cos dominates sin in the interval 0 to pi by. Till 45 cos will dominate. After that, sin will dominate. So this will be positive in 0 to pi by 4. So option A is appropriate. Did anyone get all the 4 right? Good preparation. Now you try 5, 6. Zero. Yeah, it can't be. If you take a test point somewhere between 0 and pi by 4, it will be true. But if you take anywhere between pi by 4 to pi by 2, it will become negative. Yeah, we'll discuss answers. Side. Yeah. Two more minutes. Okay, fifth one,
D.
D, ma'am.
very good. Yeah, all the others satisfied. Sixth one,
Is it A?
good, good. Yeah. What is the reason? Because this x plus y is equal to 2 is this line, right?
Yes,
And
ma'am.
x plus y less than 2 is this region. Okay. So which is your feasible region? Feasible region seems to be this, right? X and y are positive. So this region. So it's a convex polygon. So 0 to 2, and this is 2, 0. And this is 0, 0. So it can be maximized or minimized, if at all, only at these points. But z is x plus y, isn't it? So at this point, A, z at A is 2. At this point, z at B is also 2. Z at the origin is 0, isn't it? Among these values, which is the greatest? 2 is the greatest, but it is obtained at 2 points, A and B. So both are points of maximum, but that can't be the case in LPP, isn't it? That means what? All the other points also, all the other points on the line will also be maximizing it, obviously. Okay. So infinitely many points. So always remember, if there are 2 points at which your Z is maximized, that means all the points in between, all the points that lie on the line segment connecting these 2 points are also solutions. Okay. Next one.
Ma'am, option D.
Very
D,
good.
ma'am.
Very good. That shows good understanding. Yeah. A is false because it's continuous. No? How do I test? Functional value f of 0 is 0, right? He has given f of 0 to be 0. So let me find out limit x tending to 0 of f of x. If it agrees with f of 0, the function is continuous. So limit x tending to 0 of x square into sine 1 by x. What happens when x tends to 0? 1 by x becomes very large. But
So,
if the angle is very large, sine being bounded, it will become some value alpha, where alpha lies in the closed interval -1 and 1. So it's like finding out limit x tending to 0 of x square into some alpha, that is nothing but 0, okay, which agrees with the functional value. So it is continuous. So it's wrong to say it's discontinuous. How about, obviously, we don't have to test the validity of R, but I'm just showing you that limit x tending to 0 of sin x minus cos x is nothing but 0 minus 1, which is in agreement with the functional value as well. So this is correct, but first is wrong. Okay. So D is the choice. Understood? I mean, if you got these 3 correct. Actually, okay. Very good. Excellent, Sana. And Rakshita also. Very good. Okay, now passing on to 2-mark questions. Can you first try this one by one? We'll do. One more minute. Could anyone complete?
Ma'am, is it root of 1 minus x square by 2?
Final answer, is it?
So
Okay.
it I got half, ma'am.
I
Ah,
got half.
because you can always remember whenever root of 1 minus x square occurs, x is equal to sine theta will be the most appropriate substitution. So secant inverse 1 by root of 1 minus sine square theta. What is that? Secant inverse of 1 by cos theta. Okay? That is nothing but secant inverse of secant theta, which is theta. Okay. The first one is reducing to theta actually. Okay. How about the next one?
Half. I'm getting
Ah.
half.
2 theta,
Ah.
ma'am. We reduced to.
That's only good. Yeah. So 2 sine theta, x is sine theta, root of 1 minus sine square theta is cos theta. But you know, this is nothing but sine 2 theta. 2 theta. Okay. So the second function is reducing to 2 theta. So I'm asking, what is the derivative of theta with respect to 2 theta? That's nothing but half. So the derivative of theta with respect to 2 theta, that will be nothing but half. Because derivative of theta is 1, derivative of 2 theta is 2, right? Otherwise, what you can realize is that this theta is nothing but sine inverse of x, and this is nothing but 2 times sine inverse of x. So they're asking you the derivative of sine inverse of x with respect to the derivative of 2 times sine inverse of x. So you know that this is nothing but 1 by root of 1 minus x square. This is nothing but 2 by root of 1 minus x square. So 1 minus x square gets cancelled. I get half. Either way, you can understand it either way. Okay? But this is a direct way of doing it. Try this. One more minute. Fine. Can you tell me answer?
I got 1 by 4a
Plus or minus?
plus.
Plus. Okay. So did you all get dx by d theta to be a into 1 minus cos theta? Did you get that?
Yes, ma'am.
Derivative of theta is 1, derivative of minus sin theta is cos theta. So let's find out dy by d theta, a into minus sin theta. So dy by dx will be dy by d theta by dx by d theta. This is parametric, right? So dy by d theta is nothing but minus a sin theta by a into 1 minus cos theta. Did you simplify it as this? That will be easy for you.
Yes,
Okay?
ma'am.
Second derivative will be easier if you write in terms of half handles. Always remember, half handles will be handy. 2 and 2 will get cancelled. 1 sign will get cancelled. So it is minus cot theta by 2. How many of you got the first derivative correct? Right. Most of you. Okay. Most of you got first derivative, right? The second derivative is nothing but the derivative of the first derivative with respect to x. But that can be treated as d by d theta of dy by dx into d theta by dx. Okay. So that is nothing but d by d theta of minus cot theta by 2 into, instead of saying into, I can say divided by dx by d theta. Both are equivalent. So let me handle this. What is the derivative of minus cot theta by 2? That will be plus cosecant square theta by 2. But I have to multiply it by half because of chain rule. But I have to divide it by dx by d theta. But what is dx by d theta? It's here. A into 1 minus cos theta. Okay. But I want this value when theta is pi. So half of cosecant square pi by 2. You know, cosecant pi by 2 is 1, right? 1 minus cos pi. Who remembers cos pi value?
Minus 1.
Minus 1.
Cos 180. Cos 180 value you should remember. Cos 180 is minus 1. Remember, cos 0 is 1. Cos 180 is minus 1. Okay. And cos 360 will be again plus 1. And cos of 540 will be minus. Like this, it will be oscillating. Whereas sin 0, sin 180, all these will become 0. Okay. So this will be cosecant square pi by 2, which is 1. Okay. So numerator is 1 half. And then denominator is a into 1 plus 1. So what is it? You know, many students will cancel this 2 and this 2, but you shouldn't do it. How many of you got 1 by 4a? not many. So can you just copy down? Copy, Kangana?
Yeah.
Okay. So finish. Let us pass on to the next. Try this. Find the intervals in which this function is increasing or decreasing. Time is up. So shall we try first one? First derivative. Check all of you. First derivative 4x cube minus 12x square plus 8x. This has got to be 0. But we can already see that 4x is common. X square minus 3x plus 2. This must be greater than 0. So 4x into, we can factorize this further. So always remember here, it's a cubic. So you are having 3 factors and therefore 3 roots arise. So I'm going to mark them on the number line. One is 0, other root is 1, other root is 2. The entire number line is divided into 4 parts. So what you can do, you can take your test point anywhere here. Let me take it in the second interval, say half. Say half is the test point. I'm substituting half in the first derivative. So what happens? Half into half minus 2, negative. Half minus 1, negative. Negative into negative, positive. So your first derivative is positive between 0 and 1. So it will be negative in 1 and 2. It will be positive between 2 and infinity. And between minus infinity and 0, again, it has to be negative. So this negative behavior and positive behavior will be alternating. Okay. So where is it increasing? It's increasing in 0 to 1. It's increasing in 0 to 1 as well as 2 to infinity. Where is it decreasing? It's decreasing in minus infinity to 0 as well as 1 to 2. Correct. How many of you got this perfectly? Correct. Very good. This time many of you. I think it's a method of intervals, no? So many of you would have got. This is also simple. Can you try?
Ma'am, in the exam, do we need to show which test point we have taken?
Yeah. We need to show the test point.
Okay.
If you don't write the inequality also, they'll reduce marks. If you put equal to 0 and then you will solve. Okay, but they will reduce marks for that. Put the inequality. One more minute. On the derivative, Kangana. Right. Let's discuss g of x. G of x is 2 by x plus 2 by x plus x by 2. So what will be its derivative? Half. For this, half. And for this, it will be minus 2 by x square. So for maximum or minimum, first derivative is 0, right? So if I take LCM, I get things cross multiplied. Okay? So numerator is 0. I get two possibilities. Isn't it easy? Very easy. So either x is 2 or minus 2. So, but I'm not sure which of them is minimum, which of them is maximum. So I consider the second derivative. Derivative of half is 0. And minus 2 comes out. Derivative of 1 by x square is minus 1 by x cube. So I get the second derivative to be plus 2 by x cube. At x equal to 2, it is positive. So 2 is a point of minimum. This is minimum point. Okay. Minus 2 is the maximum. Because the condition that x is greater than 0. X is greater than 0. So, no, we have got possible points here. X is greater than 0, but amongst them, we have got two solutions. But amongst them, only 2 is valid because minus 2 is not there in the domain, right? Yeah. So 2 is what? Minimum point or maximum? Minimum point, isn't it? X equal to 2 is the point of minimum. Okay. And this maximum point is discarded. Why? Why is it discarded? Because x is greater than very good. Yeah, because x was given to be greater than 0 in the problem. Okay, so x can't be minus 2. So x equal to 2 is the only point of minimum. Okay. And what is the minimum value? I think he's asking minimum value, right? Minimum value is given by 1 plus 1, 2. Very good. How many of you got this right? Surprising. Surprising that not many of you got this. Hope you understood. Could you copy them? Hope you are okay with the derivative concept. 1 by x square derivative. 1 by x square, x power minus 2. So derivative will be minus 2 into x power minus 3. Just be careful about the derivative part of it. Concepts you all know, right? First derivative should be 0. Second derivative, if it is positive at that point, it is point of minimum. Okay, let's pass on to section C. I can give you 5 minutes for section C. Anyone completed?
Yes, one.
Okay.
Yes, ma'am.
Actually, time is up. That's why I asked. So the LHS limit. LHS limit means x is less than 0, right? So this is called LHS. That x in the denominator can be split because sin x by x is 1, right? But here, in order that result works, you need to multiply and divide by a plus 1. Now this will also become 1. So what remains is a plus 1 into 1, okay, plus 2 into 1. So a plus 1 plus 2. That is a plus. Understood? This is LHS limit. Just by splitting it and multiplying and dividing by a plus 1, we got this. Let's take RHS. RHS limit at 0 will be limit extending to 0. We know this is what is RHS, right? RHS means x must be greater than 0. So this part of the function should be taken 1 plus bx minus 1 by x. But I know I need to deal this as a 1. Irrational function. 1 plus root of 1 plus bx plus 1. Multiplying and dividing by conjugate. So always remember, whenever you come across irrational function, this is the only way. Okay. Numerator, you will get the root removed. 1 plus bx minus 1. In the denominator, root will remain. 1 plus root of 1 plus bx plus 1. Minus 1 plus 1 will get cancelled. X and x will get cancelled. But x is tending to 0. So this will become b by 2. Right? Okay. Now, what is the LHS limit? LHS limit is a plus 3, but the functional value also is given, right? Is given functional value here. Is given functional value here. That is f of 0, right? F of 0 is that. So we need to jot down that also. So for continuity, all these three should be same. LHS limit should be equal to RHS limit. LHS limit is a plus 3. That should be equal to RHS limit, which is b by 2. That should be equal to the functional value. So I can solve for a and b, right? If I solve for a and b, I get a to be minus 1 and I get b to be 4. How many of you got this? A is minus 1 and B is 4. Jessica seems to be well prepared. Sahana Ganesh, excellent. Sai, very good. Vinay Krish also, excellent. All right. Copy, Rangana? Yeah. Copy done. Find where this function is increasing or decreasing. Next one. Can you differentiate it? Okay, could anyone complete?
Yes, ma'am.
The times are f dash of x will be 4 sine cube into derivative of sine plus 4 cos cube into derivative of cos. But we can take 4 sine x cos x out. See if you did this. Could you get this? You can write this as minus of, I'm taking minus out. So sine square x minus cos square will become cos square minus sine. See, the idea is to make use of familiar formulas. I know cos square A, do you all recall this? Cos square A minus sine square A is cos 2A. Okay? And 2 sine A cos A is sine 2A. So we can make use of both these. So it will become minus 2 times sine 2x. And this is cos 2x. But once again, it looks like 2 sine A cos A. So that is nothing but sine of 4x. How many of you got the first derivative right? Got it, sir? This is a good way. Okay, it's a good way of reducing it. Of course, you can keep it in the original form, but there'll be too many terms to consider and too many possibilities. Why to have all that? We can reduce it to a single function. So this is the advantage. So I want this f dash to be greater than 0 for it to be increasing. So where will this be increasing? But this is the first derivative, right? The first derivative, where is it 0? That is my primary concern, isn't it? Where is sine 4x 0? Sine 4x 0, whenever 4x is any flat angle. Sine is 0 for any flat angle, like 0, pi, 2 pi, 3 pi. For all these, sine will become 0. So 4x can be 0, 4x can be pi, 4x can be 2 pi. It can be any of these. Therefore, your x can be 0, x can be pi by 4, or x can be 2 pi by 4, all these. But the interval of focus is 0 to pi by 2. So the only point where f dash is becoming 0 in this interval is pi by 4. Right? So how about taking it as point? Shall I take it as point here? You know that this is 0 degrees. This is 45 degrees. This is 90 degrees. So shall I take 30 degrees in between? Test point. So that means pi by 6. Pi by 6 if I take a test point. 30 degrees if I take as test point. What will be this? This will be minus sine of 4 times 30. That is 120 degrees. But all of you know, in the second quadrant, sine is positive. Right? Yeah. So minus sine 120 will be negative only. Understood? Sine of 120 is positive. Sine of 120 is positive. So minus sine of 120 is negative, right? That means your first derivative itself is negative here. Are you convinced or not? So throughout, because it's called method of intervals, no? I take it as point, and at that test point, if the derivative becomes negative, it will be negative throughout. So I conclude that it is increasing here and it is decreasing there. Okay. So how should I write? The final conclusion is tricky. I don't know how many of you wrote it correctly. Just check. Your f dash is negative here. Your f dash is positive here. Therefore, your f is decreasing here. Your f is increasing here. Right? How will you write it therefore? Therefore, f is decreasing in. Can someone complete?
Closed 0, open pi by 4.
That's what I don't want actually. Because at 0, the first derivative becomes 0, no. You understand, Aparna?
Yes, ma'am.
So you should make it open. Because if the first derivative becomes 0, It's neither increasing nor decreasing. Do you all know that? Points for which first derivative becomes 0, it's called stationary point. So it can't decrease or increase there. Okay. So it has to be clear cut. It has to be either positive or negative. So it's decreasing in open 0 to pi by 4. Make it open. That will only be technically correct. Even though E has included 0, okay, in the interval that's mentioned in the problem. E has included 0, but we wouldn't do that. Okay. And where is it increasing? Pi by 4 to
Pi by 2.
open or closed?
Open.
Open. Very
We can't keep it closed when.
we
pi
can't
by
keep it
4
closed
to pi
because
by 4.
at pi by 4 also we can't keep it
We
closed.
can't.
Yeah, because at those points, the first derivative is becoming 0 at the end points. Where the first derivative becomes 0, what are those points? Those are points of maximum and minimum. Understood? So they can't be in the point of consideration for increasing or decreasing nature. They can't be candidates for that. So this is only correct. Did anyone conclude properly like this with open intervals? It's monotonicity that we are bothered. Okay, so we shouldn't include the points where the first derivative becomes. It's an important point of consideration. Have your concepts very strong and clear. Then any paper can be cracked. Okay, look at this, LPP. LPP, my point of concern is your time. You should solve this within 5 minutes, can you? So by 6:15, you should complete it. I'll give you graph paper. You have. You take out your graph papers. To plot very fast. Okay, many of you take very long time and you all decorate. All that is waste of time. But draw neatly. Okay, sharpen your pencils and take for the exam. Oh. Location அமைச்சிருக்கேன். Canberra back. மேல. Okay, same. How many of you got this region? Huh? You didn't? This is the region. Good job. Many of you got it. Very good. It is actually unbounded region. No, unbounded region. And how many points arise? How many points are there in this region? Can you see one point here? Maybe we can call it as A. We can see another point here, okay, of that light blue region. There are 3 points to consider, right? This one will be 0, 4. This one will be 0, 3. Did anyone find this? This seems to arise as the intersection of L2 and L3. So we may have to solve these two simultaneously. L2 and L3. Take them up just to get the correct value. Okay. Can anyone solve this and tell me? What is it?
Got it. 8 by 3, comma 1 by 3.
8 by 3, comma 1 by 3. That's very handy. By 3, comma 1 by 3. By solving these two. Okay. Because it's the intersection of L2 and L3. How many of you got these points correctly? These 3 points. You should have. Okay. So maybe. Okay, very good, very good. So you should substitute here and find out Z at A will be 20, Z at B will be 50, and Z at C will be 3 into 8 by 3 plus 5 into 1 by 8 plus 5 by 3, that will be 29 by 3. 29 by 3 is 9 point something, no? So I think this is the least. This is the minimum most value that you get, okay? And the corresponding point that gives you the minimum is C, okay? 8 by 3. So what will you write here? What is this region called? Many of you know. What is this region? What we have shaded here? What is this region called?
Unbounded.
Huh? Shaded region. What is it called?
Unbounded.
Huh? What is it?
Feasible region.
Feasible region. Yeah, this is called feasible region. What is the feasible region? Feasible region is that which is containing points satisfying all the constraints given. Okay. But the points which optimize the function, or the points which may minimize or maximize the objective function, will all lie at the edges only. Okay. They will lie only as vertices of this convex polygon. All right. So I know that I should write the minimum of Z to be 29 by 3, reached when x equal to 8 by 3 and y is equal to 1 by 3. How many of you think the problem has been solved? No? Okay. What else needs to be done? What else should we do?
We have to plot Z.
Very good. We have to plot that iso cos line. Do you all remember? Because it's unbounded, no? There is no guarantee that the minimum is indeed reached here.
And then if it's like not related to the feasible region, then it is like
Yeah, we need to know, probably there is some point which is somewhere in the feasible region which might give you a value which is less than this, just to wipe away that possible feature. What we do, we plot, take that Z was 3x plus 5y. Equate it to the value that you got, the minimum value that you got, and plot this. Okay, plot Z at the minimum value reached. Plot this line. This is nothing but 9x plus 15y is equal to 29. How do I plot it? See, don't be, bewildered by the, huge numbers. Actually, it's very simple. When x is 0, what is y? When x is 0, y is 29 by 15, no, 1.9 something. And when y is 0, x is 29 by 9, 3.2. Okay, plot these points, 0 approximately 0, 1.9, 0, 1.9, and 3.20. 3.20. Plot these points, connect them. So what is this black line that I've drawn just now? It's nothing but iso cross line. Okay. Okay. So what's your take? What should I
29.
actually, what should I actually plot? The region that I need to plot, now plot. You have drawn this line, isn't it? So find the region corresponding to the inequality. Find the region 9x plus 15y is less than or equal to 29. We are just ruling out the possibility of some point being less than 29, isn't it? Less than this value. So 0 satisfies this. 0 plus 0 is less than 29. So region containing the origin. So which means what? This one. Okay? This is this region I have to plot. Has it got anything to do with the feasible region?
No.
No. Yeah. This region, which I'll shade in black. This one. This is the region that we got, right? Because we need to consider it only in the first quadrant, but it doesn't seem to interfere with the feasible region, right? It has got nothing to do with the feasible region. So what do you conclude? What should you write? Therefore, the region corresponding to 9x plus 15y, 9x plus 15y less than 29 has no common point with the feasible region. Okay, no other point in the feasible. That means what? There is no other point in the feasible region which can fetch you the minimum. So whatever you have got already seems to be perfect. Okay, so the region corresponding to the isoprofit actually confirms the fact that what you got already is indeed the minimum. Okay, therefore, there is no other minimum point other than what we got. So the minimum point that you got is unique. Okay, how many of you understood this? Perfect.
Can we take less, more than 29 also?
More than 29 is not our botheration. No. Actually, we want the minimum of that only. Minimum means what? It should be less. Probably this we got 29 by 3 to be minimum. Our botheration is there any other point which can fetch us something less than 29? Okay, 29 by 3, whatever. Is there any other point in the feasible region that might have, been the minimum point? That is our concern. Okay, but that's not the issue at all. That's what this isoprofit line is assuring you.
Okay.
Ma'am, if we were to maximize the function, then we'll find the
If we were to maximize, I think then it may have some possible points, no? Then that is a point of concern. But invariably, for minimum only, usually they give you unbounded solutions. So for maximizing, when it's bounded, we don't have to do it. So can you try the next one? Again, 5 minutes. You want another? Thank you, ma'am. You have it, right? Complete by 6:35, plotting of lines.
We are doing the 15th one.
Oh, I'm sorry. I'm sorry. Index plus 3. X plus 4y is less than. It's giving you a rectangle, right? Hello. Second. Yeah, 2H. Please, please go to the middle row. If we got this pentagon, seems to be a pentagon according to me. Got it, is it? Good job.
Y is also 24 by 7.
That's also 24. Oh, that's a great
This
relief.
one.
Okay. Yeah. Okay, how many of you got these points correct? Origin 0, 0, and then one more point is 5, 0. Other one is 5, 4 by 3, 24 by 7, 24 by 7. And then A is nothing but 0, 6. At these values, I need to find the Z at origin. Into Z at B, 24 by 7. Check if you got these values. And how about this? 168 by 7. I think it exceeds.
24.
Oh, that's also 24. Ah, okay, okay. Both are nice problems, actually. Got it? B
Yes.
value. Yeah, but all these should be got within 5 minutes. That's what is my concern. Okay. Always bothered about the time you take to complete. Okay, what do you conclude afterwards? After getting all these? Is that is optimized at B and C, right? Therefore,
In segment B and C, the maximum point is called.
very good. It is maximized. Z is maximized at infinitely many points. That's what you should write. So what should you write? Z at B is 24. Z at C is 24. These are maximum values. Maximum value reached at two values, reached at 2 points. So the implication is that Z is maximized for all points in between B and C as well. Therefore, there are infinitely many points at which Z is maximal. Are you all clear? In this line segment, is suppose in this line segment is where the optimal solutions lie. More than one optimal solution. So we can find infinitely many optimal solutions in this line segment. Are you okay with this? Okay. So I think we spent a lot of time here. Let's hurry. Next one is the derivative. See, remember this had come in previous years, not last year, even before that. This was for 4 months. Something like this, not exactly like this, but it came for a case study. That's why I gave this. So yes, define the LHS derivative and RHS derivative. Okay. So checking the differentiability is important, isn't it? How to test differentiability when the LHS derivative and RHS derivative happen to be same. So this function is defined as mod of x minus 3 when x is greater than 1. Okay, so can you take down this function? The function is defined to be mod of x minus 3 when x is more than 1. And it is defined to be x square by 4 minus 3x by 2 plus 13 by 4 when x is less than, it's split and defined. So one is a mod function, other one is some algebraic function. So what I'm supposed to do is that there is a series of questions here. What is the RHS derivative at x equal to 1? Okay, what is the RHS derivative at x equal to 1? So which definition holds good? This one. Okay, the RHS derivative at 1, f dash of 1 towards the right. Okay, so RHS derivative at 1. That is limit h tending to 0, f of 1 plus h minus f of 1 by h. Because it's not visible, that's why I'm writing it once again. Can you try it on your own now? Let me see who gets this limit correctly. You should know where you have to substitute and how to evaluate the limit.
-1.
Very good. She got it right. How many of you got that value? That's what I was thinking. Okay. There seems to be a weakness there. 1 plus h. Where do you substitute it? Yeah, Anirudh also got it. So 1 plus h means what? Value? What is this value? More than 1 or less than 1?
More than.
More than.
More than 1. Okay, so more than 1 means we have to use this part of the definition. Okay, so this is nothing but modulus of x minus 3. That is the definition. But instead of x, I should substitute. Did you do this? Oh, very good. Minus f of 1. F of 1, where will you substitute? Here only, no? X is equal to 1 is found here only. So here again, I have to substitute x as 1. So 1 minus 3, mod of 1 minus. Understood? F of 1 also I should substitute there only. After that, in the denominator, h. In the denominator, h. limit of h tending to 0. Could you get this much? After that, what is the mod of 1 minus 3 is what? Minus 2, isn't it? So mod of h minus 2. But what is h? H is a very small quantity, no? Tending to 0. So something like 0 minus 2. But it's negative, but mod is there. So it will become very good. 2 minus h. It wouldn't be h minus 2. Where it, if it were to be h minus 2, it will fetch us a negative value because h is tending to 0, no? Something like 0, 0, 1, something like that. Very close to 0. So that minus 2 will be negative. So I have to put it as 2 minus h, right? Minus of, what is this value? This is 2 divided by h. 2 and 2 will get cancelled. Okay. That's why she said it was minus. There is so much of matter in this. Understood? Okay. Now can you evaluate the LHS derivative yourself? LHS derivative at 1. The function is here. Try that. LHS derivative at 1. Functional form he has given.
Was it -1?
I think so. I think so. But actually we can physically differentiate and get it. That's what I did. But because he has given it as a limit, he expects you to evaluate it as a limit. So we shall do that. LHS limit is actually a quadratic. LHS derivative. I mean. We all remember the definition, h tending to 0, 1 minus h minus f of 1 by, very good, minus h. Okay, now 1 minus h is more than 1 or less than 1? Less than 1. So which part of the definition? Second one. Second one, that x square by 2, that one. There I have to substitute 1 minus h. So x square by 2, what else is there? Square by 2 minus 3x by 2. 4. X square by 4, correct. Minus 3x by 2. Minus 3x by 2. And then plus 13 by 4x, correct? Plus 13 by 4x. See, all the limits are very simple to evaluate. Don't worry. Okay. Minus f of 1. Oh, I forgot that. F of 1. Where is it? F of 1, I think we evaluated already. Mod of 1 minus 3. What is it? Mod of minus 2. Just 2. Okay. Shall I substitute that here? Which one? No? Oh, 13 by 4 x.
No, that was just the
13 by 4. Oh, okay, okay. Oh, I see. Just 13 by 4. I'm not able to see this at all. I need to check my power. 13 by 4. All right. Till this divided by minus h and limit h tends to. All right. See, what is that you have? H tends to 0, right? So 1 square by 4. So 1 by 4 minus 3 by 2 plus 13 by 4. We have still not, there is a villain in the denominator. H tends to 0. H tends to 0. Shall I have it like that? Minus h I inducted to denominator of the numerator. Let me expand the numerator and see what gets cancelled. 1 minus 2h plus h square minus 6 plus 6h plus 13 divided by minus 4h. What is it? Was there a 13 by 4 over there?
We took 4 down, right?
Minus f of 1, I didn't do, right? Minus f of 1 was 2, right? Four was the LCM. Minus 8. Oh, that's why I was wondering why the constants are not getting cancelled. They're getting cancelled actually. Limit h tending to 0. What we have in the numerator is h square plus 4h by minus 4h. What comes out from numerator? H, no? H into h plus 4 by h into minus 4. H and h will get cancelled ultimately. But I'm sure you would have got it effortlessly. So, but you need to arrive at it. That's his intention too. He wants you to arrive at the derivative using the limit method. That's why he has defined it as a limit, right? So better keep this in mind. This is the way LHS derivative and RHS derivative would be evaluated. Okay, theoretically, that's the way to find it. Of course, we can also find out without much effort just by looking at the function and differentiating it. So what would be your answer for this? This fetches you 1 mark. You should write -1 here. LHS derivative. This we have evaluated just now. So all these fetch you 2 marks. Check if the function is differentiable at, yeah, we should take this, isn't it? Is it differentiable or not? Huh? Yes. Yeah, because the LHS derivative and RHS derivative are same. Okay. Therefore, because LHS derivative is equal to RHS derivative, therefore it is differentiable. Okay. Find f dash of 2. Okay, can you find who's going to find f dash of 2?
-1.
Huh?
-1.
Very good. F dash of 2 is also -1. What is the reason? Because it's mod of x minus, that one you should take. What is 2? 2 is more than 1 or less than 1? More than 1. So you should take this part of the definition. Okay. So how does this function behave at x equal to 2? Is it mod of x minus 3 or 3 minus x?
3 minus x.
At 2. Very good. 3 minus x. At 2, it is 3 minus x. Only then it will be positive. No, what is its derivative? Minus 1. It is the derivative of 3 minus x. So that is minus. Understood? What is f dash of -1?
-2.
She got -2. But how do you get it? From where will you get it? Where, what is -1? Is it more than 1 or less than 1? Less than 1. So you should take which part of the definition? Second one. Very good. Yeah, you got it. This one. This one, I need to differentiate. Okay, let me get it right this time. So what is the derivative of this? This algebraic function gets differentiated as 2x by 4, it's minus 3 by 2 plus 0. Correct? Slash. At what point do I want? I want the derivative at -1. Correct? Substitute x is -1. So I get -2 by 4 minus 3 by 2. Yeah, perfect, Aparna. Very good. Minus half minus 3 by 2, which is -2. Understood, all of you? Because here you don't have to do by limit method. Okay. So you can just find out the derivative by algebraically differentiating it and getting it, not using the limit method. The case study. Your favorite. Okay. Do it yourself. Five minutes. All case studies should not exceed 5 minutes. Okay, do it yourself. Time is up. I'm sure you would have thought about the problem. So let us construct the cost function. We have got a tank which is to be square based, right? Did you all take it as x into x, and then height is some y? So how many of you realize that x square y is 250?
It's fine.
Yeah, volume is 250, right? And the cost of the land is 5,000 per square meter. So which is the land that the tank is occupying? What is the land that it would occupy? This one, no?
It's
This is the land. Okay, this is the land that it occupies. So what is the area of the land that it occupies? X square. Very good. And the cost of that is
5,000 is fine.
5,000. Therefore, the total cost is going to be 5,000 x square. Did you realize that? 5,000 x square plus, but he has given the cost of digging is also involved. That increases with depth. It's a direct proportion to your depth, and it is given as some 40,000 x. How many of you were successful in constructing the cost function? Cost is this 5,000 x square. Very good. You have very good common sense. Yeah, that's all it is. Okay, so this is the constant condition. And this is the cost function. This is to be minimized or maximized. Minimize the cost, obviously. Okay, if you construct these two, that's all there is in maximum minimum. After that, what are you supposed to do? Oh, okay, here. Find the cost C of digging the tank in terms of X. Okay. We got the cost in terms of X and H, but I have to get it in terms of X. So for that, what should I do? I should make use of star. So this is 5,000 x square plus 40,000 into, what is H? Oh, here.
40 by X.
I had taken it as Y actually, but it is actually H. Isn't it? So 250 by x square, the whole square. See, but I know personally that some of you actually like to do case studies because you have a good common sense. So 625.00. Oh, okay, fine. So we have to minimize this cost. Okay, we have answered the first part. Next one, find dc by dx. Did you do that? What is dc by dx? It will be 10,000 x. Okay, 10,000 x. And then how do I differentiate this? X power 4 in the denominator. No, x power minus 4. So how do I differentiate that? Minus 4 by x power 5, is it right? Into 40,000 into 625.00. Okay, so find dc by dx. Okay, I have to minimize it. So for minimum, this should be 0. Or in other words, 10,000 is common. 10,000 x power 6 minus 4 into 40,000 into 625.00 is equal to 0. So from here, what can I take out? I can take out 10,000. So x power 6 minus 16 into 625.00. So x power 6 should be 16 into 625.00. Did anyone find this? What is 16?
The x power x 10 is what I got.
Oh, okay, very nice value actually. Okay. Yeah, I didn't expect this. It's a pleasant surprise. So x power 6 is this much. So x is 10. Very good, Nishant. That's what. How many of you got this correct? I was thinking it is leading me to something very nasty, but oh, many of you got it. Very bright. Yeah, x is 10. Okay. X is 10 means what? The base is 10. How about height? Height I should find out. No? As he asked for the height, check whether the cost function expressed in terms of x is increasing or not, where x is greater than 0. Oh, okay. Nice problem. Is it increasing for x greater than 0? Cost function already we know first derivative. Is the first derivative positive or negative? What is your take? Is it increasing or decreasing? C dash of x is here for you to inspect. Is asking whether this is positive or negative. Is it increasing or decreasing? Huh? Decreasing. Why? Increasing. Why? He's asking whether this is positive or not. This is your first derivative, right? So he wants to know whether 10,000 x power 6 is more than is it more than 0? That's what he's asked. We equated it to 0 for maximum minimum. For increasing or decreasing, we want to know whether it is positive or negative. Is it positive or negative? You have to factorize and decide. So it's positive when x is more than 10. For x is more than 10, it's increasing. For x is less than 10, it's decreasing. You get that? I think it's a nice problem because it combines the concept of maxima, minima, and increasing, decreasing. So this is where many students get confused, actually. Are you all okay? It is positive. Your first derivative is positive when x is more than 10. Okay. So it's increasing in which interval? 10 to infinity and decreasing in minus infinity to 10. How many of you could conclude this properly? I think some of you couldn't. You probably didn't realize it. See, another possibility is that a straight problem for 5 marks on maximum minima. Can you try this? Okay, don't take more than 5 minutes. Okay. Follow? How many of you could do this? Yeah, Abhana has done. Okay. Vinay Krish. Anirudh also. Yeah, these are standard problems because why I gave this problem, sometimes they do ask such a problem. See, the popular problem for 4 marks would be a case study. Case study would be usually what? Your application of derivatives, maxima, minima. And then case study can be your vectors, case study can be your probability, case study can be differentiability. All these I've seen. But sometimes they give you this for 5 marks. That is also possible. Within the possible combinations, they can try various other distributions of the marks. So they might give you a maxima, minima as a 4 marks. That's not ruled out. I've seen this in other region papers also. So that's why I gave this as an extreme possibility. Okay, so we have some time left. Shall we do vectors now? Shall we start from MCQs or from case study? MCQs, okay. Finish the first 5. 5 minutes. We're going to do fast and finish this. Anyone completed?
Yes, ma'am.
I think that's all that I require. All are very simple problems. So what we need to consider, whenever modulus is given, try to square it. Okay. So that is the clue that I can give you. Whenever problems involve mod, so you need to square that because it's the square of the vector or the dot product of the vector with itself. So you will get this, right? Plus the dot product of everything, but they are mutually perpendicular. So what will happen? All these will vanish. Okay. So it will be simply given a square plus b square plus c square, but they are what? Equal magnitude a. Okay. So everything is of magnitude a. So a square plus a square plus a square. Understood? They're mutually perpendicular. So second term vanishes. First one, all their magnitudes are equal. So a square plus a square plus a square. So what is mod of a plus b plus c whole square? That's nothing but 3a square. Okay. Therefore, what is a plus b plus c? It will be root of 3. Did you get it? Next one. A bar plus b bar. No. What is the locus so that they are orthogonal? What is your answer?
Circle, ma'am.
Very good. Correct, Anirudh. Yeah, because what is the dot product between them? 1 minus x
Yes.
square
Minus x square.
minus y square. That's equal to 0. Or x square plus y square is equal to 1. Do you all know it's a circle? Okay. Next one. A mod of a cross b. Mod of a cross b is
20, ma'am.
Ah, very good. Correct. Correct, Jessica. So AB sin theta is 4. AB cos theta is 2. So square and add. So get a square b square into sin square plus cos square is equal to 16 plus 4. A bar plus b bar is given by, did you add? 4i plus j minus k. What is a bar minus b bar? Minus 2i plus 3j minus 5k. What is the dot product between them? Minus 8 plus 3 plus 5.
0, ma'am.
Therefore, what is the angle?
Pi by 2.
Very
By
good.
2.
Dot product has become 0, so it's pi by 2. Next one, direction cosines. I think very easy.
C.
That's
E,
all.
ma'am.
Try 6, 7, 6 and 7. Of course, some problems on probability are there, but we'll stick to just vector and 3D. If time permits, you try that also. I'll give it 2 minutes. Come on, finish these. Did you complete? Okay.
Yes.
First one, what is the answer?
70 by 11.
A.
Very correct. 70 by 11. Did you all adjust the denominator? So to write that as x minus 1 by minus 3 is y minus 2 by 2p by 7 is equal to z minus 3 by 2. Okay, you have to bring it to the standard form. Similarly, this one you have to write as x minus 1 by minus 2p by 7 is equal to y minus 5 by 1 is equal to z minus 6 by minus 5. After that, you need to equate the dot product to 0 and get the value to be 70 by 11. Next one. What is the angle between these two?
90.
Yeah,
90.
dot product between these two. Okay, that is 90 because the dot product happens to be 0. Next one is probability actually. Okay, let us take this assertion. Go to this. Try these two. I think both are simple, no? You must have completed by now. Tell me what is the answer for the list.
Both are A, ma'am.
Very good.
Both are
Both are A. Very good. Understood? Because when A and B are, say, on the plane of the computer, then where will A plus B be? Suppose A and B are here, A plus B will be here, right? Where will be A minus B? That will be here, right? So that means both these are in the same plane as that of A and B. Already we know that A cross B is perpendicular to A and B, so it must be perpendicular to A minus B as well as A plus B. Okay. So I think this is also easy. No, the dias must be proportional. So can you try these? First one you try. Find the value of lambda.
Ma'am, I'm getting lambda is equal to 8.
You got
8.
8. Perfect. Very good, Jessica. Okay. How many of you got 8? Got it, is it? Okay. Okay. Try this. The points ABC with position vectors ABC are collinear if and only if sum of their cross products is 0. Did anyone prove this? 14th one?
Collinear means parallel, right, ma'am? So cross product will be 0.
The points, points are collinear. So first of all, let's try and understand what he has given. He has given you 3 points and their position vectors are given. Okay. Position vector of this is given to be A bar. Do you all know position vector means what? That OA, OB, OC, no? That is being given. Okay, this is A bar. This is B bar. This is C bar. That's what he has given. Did you understand that first? He has given you position vectors that you have understood. Okay. What are you supposed to prove? What is given? They are collinear. Okay. What is meant by collinearity? 3 points are collinear means they lie on a line, right? ABC lie on a line. So like what Anirudh said, they are collinear if AB, BC are collinear, parallel. In terms of points, it has a different implication. Collinearity means they lie on a line. Okay. The points ABC or collinear means they lie on a line. Okay. That means this AB, BC will be collinear, or in other words, AB cross BC is 0. That's the implication. So if you understood this, that's what he said. He got the point. Okay. AB cross BC should be 0. But what is AB? AB is given by OB minus OA, right? Cross OC minus OD, that should be 0. But these are being given to you. This is nothing but B minus A. This is nothing but C minus B. So consider the left hand side. This is nothing but B cross C minus B cross B minus A cross C plus A cross. This is equal to 0 given, right? Or in other words, B cross C, this is 0 anyway, plus C cross A plus A cross C. Hence, understood? Could anyone manage this? Could anyone do? Only unable. Did you understand? Follow. A, B, C are three non-zero vectors. See, let me tell you one important aspect of any board exam. Don't leave anything, okay? Because sometimes it may be out of syllabus, or sometimes they may decide to give you marks just because you attempted it. And they may give you liberal marks for saying something relating to the problem. Okay, the marking scheme may be so devised that, if the paper turns out to be difficult, it's all the more, better for you. Okay, because you'll be in a better state because they will give you marks liberally. When the paper is tough, evaluation will be tough. I mean, evaluation will be easier. If it's simple, evaluation will be tough. But you should not leave any question at all. Okay, just because you don't seem to have any clue. Say something relating to it. For example, in this problem, what can you say? Whatever you need to understand, you have to understand. And whatever you can say, you should say. Okay? Can you say something about this? Whatever you understand. For every step that you do, they'll be rewarding. That's why I'm saying. Just because it's seemingly difficult, you should not leave it.
We can try and
Yeah. See, from here, what do you interpret? A cross B is C. From this, what do you understand? C bar is, therefore, 1. No, ABC are 3 vectors such that A cross B is C. So what is C bar? C bar is A cross B. Therefore, C bar is perpendicular to?
Both A and B.
That's what you should know. Okay, this is important. Okay, all of you take down this. If you say this, they will give you half a mark. Always remember, if X cross Y is Z, Z is perpendicular to X. This is something very, very fundamental in vectors. They would expect you to know this. If you don't know this, then you are fundamentally weak there, right? That is the conclusion. Similarly, can you interpret this? What does this mean? A is correct. A is perpendicular to BS. Okay. So from here, what can I get? From this, what will I get? C is perpendicular to A and B, right? That means C dot A is 0. C dot B is 0. And from here, what will I get? A bar is perpendicular to B and C, right? So I'll get A dot B also to be 0. And A dot C is also 0. But of course, that is something that we had already. It's redundant. But from these three, what do you conclude? They are mutually perpendicular. Okay, hence proved. Understood? We proved the first part. So sometimes they may give you marks for one aspect of that more. For example, if you prove this, they may give you 1.5 marks because it's a tough problem. But it is something that is so very easily derivable, making use of just the definition. So that's why I'm telling you not to leave any problem. Say something relevant to whatever is given there. Say something. Okay. Don't leave it altogether. Can someone prove the second part? Second part is a little bit harder. It's not totally difficult, but it's harder. Slightly harder.
To say like as if we don't want we are taking it from the.
From these only, from these two, they are asking us to, from what is given here only, they are asking you to prove this. So you have to make use of these and prove this.
But earlier in the statement, C is perpendicular to A and B.
That we have proved.
It
That
is
we have
C.
already, first part we have proved. Second part.
C is equal to. I'm melting this.
There is a very important aspect of equality of vectors. When two vectors are equal, what is equal? Their directions are equal and
Cosines.
magnitudes are also equal. That's what they want you to understand here. So A cross B is given to be C, right? A cross B is C bar. So if you understand the basic aspect of equality of vectors, you are through in this. And then B cross C is A. So what it means is that mod of A cross B is mod C. And mod of B cross C is mod A. Okay, can someone tell me what is mod of A cross B? Definition?
Mod A mod B sin theta.
Very good. Mod A, mod B, sin theta. What is theta?
90 degree.
Very good. 90. Don't forget, we just proved that they are at 90 degrees, right? Similarly here, mod B, mod C, sin 90. That's equal to mod A. So we seem to get two scalar equations. We have to manage that. So AB is C and BC is A. That's what we get. From these two, I'm supposed to prove whatever he has asked me to prove. Okay, anyone? How do we make use of these two? What do I do with 1 and 2? Multiply 1 and 2.
Multiply and divide.
Very good. So I'll get AB square C is equal to AC. A and C will get cancelled. So B square is 1. So B is 1. Hence proved. Okay. Now consider 1 divided by 2. So I think they will ask you only simple questions, not very difficult in vectors. So, but simple ideas should strike. Now, for example, if you don't know that cross product means a vector which is perpendicular to the given vectors, or if you don't know that equality of vectors actually is all about not only the direction, but also the magnitude. All these things, little things should strike. So many students tell me, we actually don't know how to start a problem in vector. If you know concepts, you will start, right? If you know little concepts, you will start. So AB by BC is equal to C by A. I'm dividing first equation by second equation. Or in other words, A square is C square. So A is hence proven. They're asking us to prove that either B is 1 or A is C, correct? So we got it from two true equations. Could anyone crack this before I did? Okay, that's fine. That's fine. You got exposed to this. But some problems like this are possible. But what I'm saying is that say something relevant to whatever you know or whatever is being asked. Okay, do some justice to it to the extent possible. You will be amply rewarded. Don't. Next one. Find all vectors of magnitude 10 root 3 perpendicular to these vectors. Can you just tell me what he is asking? What is the vector perpendicular
The
to
cross
the vector?
product.
Very
We
good.
have to
Find the cross product.
And then the unit vector and then multiply it.
Very find the
Root 3.
cross product, divide it by its magnitude, and then multiply it by 10 root 3. That's what he is asking. Okay. Next one. Find the distance of it from this line. Can someone tell me? What is the shortest method of doing it? I want the distance of this from this line. This perpendicular distance I want. What should I do?
Dot product 0.
Which is dot product?
We take the
Oh.
pointer.
Okay. So B can be got in terms of lambda, isn't it? 3 lambda minus 3. Understood? 5 lambda plus 4 and 6 lambda minus 8. So the DRs of the baseline are 3, 5, 6. Right? And DRs of AB are 3 lambda minus 1, 5 lambda, 6 lambda minus 3. Understood? So that's what she said. Dot product is 0. So I can fix lambda, re-substitute it here, get the distance. Understood? Understood? So in case they ask you the image will be down below. So we can get it. Okay. But I think you've become very tired. So I don't know why.
No,
But
like
I think you should have that resilience to work hard, okay? Because an important exam is coming. Of course, some of you have that in you, the fighting spirit, but some of you seem to give up very early. So, okay, I'll send you this paper, you try and complete.
got it.
Okay, so day after tomorrow, shall we have a class? Tomorrow you can take the rest of the topics. Integration, integration, definite and indefinite, differential equations and areas. Just these. Test. Similar to this. Day after tomorrow. Not tomorrow. Tomorrow I'm giving you a break. So day after tomorrow, you come prepared with these. 60 marks we'll have a test. And Thursday we'll do a cumulative paper. With that we'll wind up. The Friday you can have your own time. You can do some 5 or 6 papers on that day and get prepared for the exam. Okay. So that's the plan. So tomorrow I think we'll be completing the rest of the topics, remaining 4 topics. So theoretically from our side, we are completing all the topics, but I will send you both these papers with the solutions. Go through, I could see some weaknesses somewhere, okay, in many places.
No,
So,
actually, these few like continuity and application of derivatives, motto, I actually would like some suggested sums that can help me out. In case I want to make it thorough and finish it off, ma'am. Just sitting again and again kind of gets you.
But first you should be thorough with concepts,
Yes,
So if you understand the concept very well by doing one problem also, it will help you to understand millions of other problems. So getting the concept right is very important.
so textbook.
Textbook pandalam. That's what I'm saying. So let's meet day after tomorrow. Okay, but till then, keep working. Okay, don't give up. And you should know that you're facing an important problem. Don't relax now. Keep working.